So this morning we have a presentation by David Karnowski, radio amateur KN6IRV. Dave is a self-titled pandemic ham, having been inspired to finally earn this ticket during the onset of COVID-19 in the spring of 2020. He currently serves as the system administrator and AV tech for the National Museum of the Surface Navy aboard the Battleship Iowa. David is also a new associate member of BIARA. Please welcome David Karnowski as he presents a glimpse of what the future of amateur radio might look like in a world braided with generative artificial intelligence systems. I'm going to ask everybody to mute. And by the way, since there are so many Davids on the ship, we refer to him as DK.
Thank you, Tom.
From this point forward.
Thank you very much, sir. I appreciate the introduction. I realize that I've met a lot of you folks, and for those of you that I haven't, thank you for taking the time to have me present this project. What I'm going to present is a project that I spent quite a bit of time on, and it is on capturing, classifying, archiving radio amateur transmissions. And let me go ahead and share my screen so you folks can see this, and maybe someone give me a thumbs up when it is sharing. Thank you. Just a quick disclaimer for you folks before I begin, and that is that I am not an engineer. I am just some guy with a MacBook Pro. So please, grains of salt are definitely necessary with my project. If you find that I'm lacking on some technical information, please bring it up afterward, because the parts of this project that need improvement are valid as input, and I would appreciate the criticism. And as Tom said, I am a pandemic ham. I call that myself. I'm self-titled, and that's because I decided to get my ham radio license during the pandemic. My name is David DeWitt Karnowski, not to be confused with the David Karnowski that's an actual computer scientist up at the University of Wisconsin. I am radio amateur KN6IRV, and I am an AI enthusiast and lifelong computer nerd. I'm a former independent multimedia journalist, a cybersecurity professional, and ethical hacker, and I'm currently serving as the system administrator for the National Museum of the Surface Navy at the Battleship Iowa. And I like waves. All the waves. Especially RF waves. And I blame this guy, and you might recognize his face if you're an avid amateur, especially if anybody gets on YouTube often. So this is Josh Nass, KI6NAZ. He's based over there in North Orange County. And he's been publishing on YouTube for quite a few years now, and his face and this thumbnail came across my screen back in 2017. He told me that I could listen to almost all radio frequencies for $20 with this little USB dongle. And I took the bait. I paid the $20 on Amazon. I got one of myself, a little tiny kit, little tiny dipole antenna. I had no idea what I was doing. But I quickly realized that you hear some interesting things on SDRs. So I quickly found that stumbling around on the frequency and exploring this part of the spectrum that I knew existed, but I'd never really taken the time to look around and tune around on, especially on frequencies that I never owned a receiver for. So finding and stumbling across the KFC drive-through headset around the corner from me was eye-opening. It made me realize that there are things that are happening all around us in radio that I just, as a layperson, and at this point in my progression in electronics, I didn't even understand ham radio, and so I guess I just didn't even know that it existed. But it did inspire me to become a ham radio operator. I heard the hams on 2 meters and 440, and I could hear the repeaters and the nets, and I wanted to speak back. And this is something I had considered when I was younger. The code requirement had always kind of concerned me. But when the pandemic took hold and the FCC greenlighted online testing, I jumped at it. I became an amateur radio operator, KN6IRV, tested for my technician test as one of the first 3 online rounds with GLARG, the Greater LA Area Radio Group. And then I upgraded to my amateur general in fall of 2020. I quickly became a simplex junkie, 146.52 megahertz, 2 meters FM simplex call frequency. What I realized was that with the cheap HT that I had, of course, a Baofeng UV5R that all new hams, or most new hams, get when they realize they need a radio, that's what I could hear. And so that's what I found, and I made contacts, and I was amazed by that. And I did what most hams do, and I built an antenna, made myself a quarter wave ground plane, and bought a mobile rig, made some more contacts, and of course built another antenna. I bought another radio. I made more contacts, and but mostly what I did was I listened, and this was from my roots of listening to the SDR. But what I heard on frequency was all of life. Essentially, I heard friends conversing. I heard hams boasting. I heard knowledge being passed and grounding advice being given. Signal reports, good and bad. I heard bullying and bigotry. I heard happiness and joy, and I bought another radio because that's what ham radio operators do. And then I started on what would become the most comprehensive technical project that I've ever taken on in my life. It was called SoCal Simplex Archive. I did it on YouTube. And what is the SoCal Simplex Archive? Well, simply, it's a monitoring station. It's a RF transmission collector and archive, a metadata database, and it's a 24-hour, 365-day-a-year YouTube live stream. So after 2.5 years, and with a 97% uptime, 2,500 live streams completed, the SoCal Simplex is still available online. And if you have another browser open, or if you want to take down this URL, you can. It's available at youtube.com/@SoCal Simplex Archive. The account was created in March of 2021. It started 24 streaming onto YouTube in April of 2021. And every stream since has been archived. Ended streaming in September of 2023 with over 350 subscribers and more than 100 YouTube short videos. And the archive's initial components for the hardware chain were rooted in software-defined radio. We started with that same RTL SDR blog software, SDR. We used an Ubuntu Linux desktop system because that's the flavor of choice that I have, and using GQRX open source SDR software, which some of you may have experience with. I used Open Broadcast Software, OBS, for the live streaming, and that basically captured the window of GQRX and pushed it out to YouTube, and of course YouTube itself. And this is what it looked like. It was very basic at first. It essentially was a modulation waterfall pushed out to YouTube. The squelch was turned up, so you wouldn't hear static when you first saw it. This was from March when I was first testing my streaming. It was not when we were streaming 24 hours. And if you came back to play the video, you'd wonder, what's the point? This has no content on it. And what you could do is you could stream around, or you could scroll around on the timeline and actually find the traffic that you were looking for, find previous contacts, find your
CMGWB 6 Mexico Yankee Lima. Good evening, sir.
So essentially it was just playback. It was like a DVR that you could go back and listen to the playback of the simplex frequency. The clock at the bottom there was overlaid in OBS. It was terrible, hard to read. I doubt on your screen you can see it. I can barely see it on mine in full screen. It says Tuesday, March 9th at 2021. There's no UTC time. It was simply based on the local time. So it was missing a lot. And I also realized within the first month that I needed to downsize the hardware. I didn't want to be running a PC completely. And who doesn't like Pi? So I reduced the power in the system to a 12-volt system. I started running GQRX on a Raspberry Pi 4. And I picked up a dedicated hardware streaming encoder that was capable of taking the HDMI output of the Pi as input, turning that into a stream that would directly go to YouTube, thus eliminating the OBS and the need for a full PC. But you're wondering, where's the antenna, Dave? Are you all mouth, no ears? No, it was definitely an antenna, obviously, and it was at first that exact same one that I described, a DIY SO239 bulkhead connector with a quarter wave element, stub antenna. It used welding rod elements, and I tuned it with a nano VNA, and I cut it directly for 146.52. So where's the beef? What is the point? Who cares? And why are you recording hams? Well, I'll let this guy explain.
Hey, what's up, everybody? I'm Adam from K6ARK Portable Radio. There was an interesting event in ham radio over the weekend where some local Southern California stations made contact over 2-meter simplex with a station in New Hampshire. How might that happen, you might ask? Let's take a look and see if we can figure it out. First things first, I want to introduce you to a YouTube channel called the SoCal Simplex Archive. This is a new channel set up by a guy named David, and he hooked up an SDR to a quarter wave vertical antenna at his home QTH there in San Pedro. near the Port of Long Beach. And he monitors 146.52 simplex and streams the received audio and the waterfall to the internet over YouTube. So here's his YouTube page. You can see a little bit of an about description and a slew of videos here. Morning, afternoon, and nighttime is typically how he breaks them up. And one of the cool things about this is that you can go back and listen to recordings. Say if you were doing a SOTA activation and you want to hear how you sounded in the LA area while you were operating from a local SoCal summit. The other cool thing it does is that it gives us a way to look back on this odd event and try to figure out what happened. So let's take a listen. This occurred on Saturday, July 24th, starting around 10:30 in the morning. Let's take a listen here of the first time that the New Hampshire station comes up on this local SDR receiver.
NE1B, New Hampshire.
So we hear QRZ NE1B, November Echo 1 Bravo, New Hampshire. That's kind of odd and interesting to hear.
And folks, I'll go ahead and I'll pause the video there. And the point that I want to make with it is that Adam is describing a situation that happened, a propagation event in the summer of 2021 that was very odd, to the point where the propagation didn't make sense to be a natural occurrence. And what ended up doing is he debunked the situation, and he pointed out where there was some digital dropout in the signal, thus indicating a likely internet connected repeater system, or two radios connected via the internet. And the point of this is that Adam uses this to make dinner. If you're not familiar with Adam's channel, he's an avid soda operator here in Southern California, and he also is a YouTuber. He uses the SoCal Simplex Archive capture to debunk what happened, and therefore executes on frequency accountability. And I think it was one of the most, it was one of the most immediate, after we started the stream, one of the most immediate and obvious situations where there was benefit to a public stream archive. And that's what a public stream archive does. It gives objective signal reports, it allows for self-testing, it provides past log review, and it enables accountability on frequency. So between the summer of 2021 and fall of 2022, the SoCal Simplex Archive kept streaming. The antennas progressed from a DIY quarter wave ground plane to a single band Tram Browning 1400 by fall of 2021. And then in 2022, we did switch over to a Diamond Super Gainer 7500 mobile antenna. I experienced a hardware chain failure at the media encoder, where the device just literally stopped working. I had to switch back to a dedicated PC running Ubuntu again. And I had mixed reactions by amateur radio operators about the stream. Some, like Adam, found value in it, while others were quite honestly shocked that they were being recorded and put on YouTube. Now, when we have a situation like this where ham radio operators are transmitting on our frequencies, most hams realize that anyone with a radio can listen to what they're saying. So the expectation of privacy, well, there is no expectation of privacy in ham radio, but to watch the reactions was interesting to me, and it actually at one point discouraged me. I even let the stream drop for a couple weeks in the fall of 2021, but I was encouraged by some other local hams to continue operating, and so I did. I put it back online. And that's when the jamming started happening, and it was significant. The jamming occurred as repeated key-ups without ID, maliciously timed APR bursts, fast, goofy sounds, computer-simulated voices, racial epithets, bullying and bigotry, transmitting of licensed music, and whistling. And this jamming, well, I think it's always occurred, obviously, in ham radio, and perhaps part of the project and documenting these transmissions just made it more obvious and more searchable, or where we could identify it a little bit easier. But there was some specific jamming events that happened that ended up culminating pretty badly at the end of August in 2022. And I'll let you view this video.
The 2-meter national simplex call-in frequency in the Southern California region has experienced an increased amount of malicious jamming that culminated yesterday evening into a climax of sexually obscene, harassing, and racist transmissions. In the late hours of the night, 2 significant signals were observed on 146.52 megahertz from the SoCal Simplex Archive listening station in San Pedro, California. both describing sexual acts and using racial slurs. The culminating event on August 20th began and continued to escalate between the local times of 21:20 and 22:50, with signals that appeared to have originated from two different transceivers. Both signals were observed transmitting the heinous commentary at the same time, indicating a dual radio operator setup or a jamming event with multiple stations. The observed transceivers' carrier frequencies were approximately 1 to 2 kilohertz apart, and the simultaneous transmission would suggest that the jamming did not originate from a single radio, with its signal obfuscated by way of varying antennas, microphones, or RF gain settings. In the past few months, malicious mic key-ups and unidentified transmissions with whistling and breathing have been observed by the SDR monitoring stream operated for the last 18 months by KN6 IRV. Frequency regulars such as KE6ZGR in Little Saigon also report hearing bong hits and purposely timed APRS transmission bursts. More recently, the frequency has been overwhelmed in the South Los Angeles and North Orange County areas by transmissions of copyrighted material such as music and broadcast television programs. While some of the APRS bursts have been decoded and stations contacted, the occurrence of such transmissions seem to have increased significantly over the past 6 months. One of the two signals was distinctly recognizable as having previously self-identified as Craig Denny, aka KN6GLC. Contributing factors to this ID including the overwhelming signal strength observed by the SoCal Simplex Archive listening station, indicating a nearby or very powerful transmission source. KN6GLC has an address listed on their FCC license record as being a mere 0.61 miles from the YouTube livestream in central San Pedro. Additionally, the human voice heard on the jammer signal was recognizable as previously self-ID'd transmissions by a station claiming to be Denny on multiple past dates. The other jamming transmissions observed yesterday evening have a lower signal strength, and the station operator appeared to purposely disguise their voice. The two apparent jammers seemed to spar back and forth at times, but both openly taunted someone named Fred, assumed to be longtime SoCal ham Fred Fikes, aka KN6OS, self-described voice of Cerritos. Other comments transmitted by the station ID'd as KN6GLC included what some might consider taunting and harassing commentary about cats, and are assumed to be targeted at another seasoned Orange County operator, Dale Goptik, KE6ZGR. The station assumed to be KN6GLC also appeared to warn the other jamming station that the frequency was being recorded by, quote, KN6 FBI, end quote. The recent disruptions to the simplex calling frequency haven't gone without return threats from the openly identified stations who claim to be tracking the jammers. Reference to the mental health, work ethic, and physical well-being of the malicious operators have been expressed on multiple occasions, including threats to target the jammer's place of employment, his radio equipment, and person. By 22:50 Pacific time, the malicious jamming transmissions had diminished, and 146.52 megahertz, as observed in the Los Angeles Arbor area, was quiet again.
Well, fuck what he said. You fucking goddamn fucking the fuck out of town, dude. Let's go, nigger.
So you can see, and I apologize, I didn't give you folks a kind of a little bit of a warning about language and the content of that video. The jamming situation on 2-meter simplex here in Southern California, North Orange County, it reached a boiling point during that summer, to the point where we weren't able to leave our radios on around our kids. That the whistling, the jamming, the racist comments became so intense that, well, we decided to log it all. And I realized that in order to do something like that, to be able to create reports about the jamming, to have transmission timing, to be able to file an FCC report with enough information that they could actually take action upon it, I needed to log it in a way that was mechanized. And to do that, I needed a Python-powered logging squelch. Because capturing signal metadata requires coding. And I was already enrolled in the Python class at the local community college here at LBCC. I had experience with hobby-level Raspberry Pi Python projects. The transmission tracking I knew would enhance the archive. And so I explored GQRX remote commands, and I started coding. But something unexpected happened as we were finishing our semester at the fall of 2022. And that was that ChatGPT was released to the public on November 30th by OpenAI. I received an A in my Python class on December 15th. I signed up for my own OpenAI account on December 16th, and by Christmas, I made Santa dance.
Good morning, everybody. It's Christmas Day. Did you look underneath your tree? Santa Claus left you a brand new radio or some gifts you didn't unwrap this morning. KS6 West out here by Nosbury Farm. We seen Santa Claus leaving the area.
And of course, what we was able to do, we were able to integrate the signal reporting coming in from GQRX, integrate that into the YouTube API, and act upon it, giving live signal feedback to viewers of the live stream. And we did that in GQRX using its remote commands that are available by Telnet Socket. I was able to do things like access directly the SDR signal strength. I could grab transmission logging and actually give start times, stop times based on that signal strength. And it enabled me to utilize GQRX's built-in recording system. So I could initiate a recording by sending an acquisition of signal command into GQRX, and I could end the recording by sending a loss of signal. Obviously, satellite terms, GQRX uses it to start and stop their recording system. This gave me wave file output based on the actual start and stop time of transmissions, which is critical. And this is what it looks like. This is what a software squelch operates like. This is the actual loop. So when a received signal is above the threshold for logging, it triggers an averaging loop that then attempts to decide if that's a transient spike in the noise floor or if it's an actual elevated signal. So it reads 5 more signals 20 milliseconds apart, attempting to determine that. And if that is the case, then it initiates the timing tracking for the individual transmissions. And so the result is a program based in Python for SDR signal monitoring called SignalBot. SignalBot pulls the signals in from GQRX. It controls the GQRX recording functionality. It reports the signals to YouTube livestream via chat via the API. It manages the daily YouTube livestream transitions, and it logs transmission metadata into CSV sheets. And this is kind of a glimpse at what it looked like in operation.
Jack, go ahead.
Okay, this is 2 watts. 1, 2, 3, 4, 5, testing on 2 watts. Okay, I'm going to go up to 4 watts. This is 1, 2, 3, 4, 5 on 4 watts. And then we're going to go up to 6 watts. And this is KI6RF testing. And we're going to go up to 8 watts. And this is 1, 2, 3, 4, 5, 8 watts. And now we're up to, most I can get out of the radio is 9 watts. Over.
Okay, go down to 2 watts. Go down to 2 watts and give me...
So you can see there's 2 ham radio operators that are currently in a QSO doing a radio test. Jack's down there, KI6RF in San Diego. Fred, KN6OS, is down there by Knott's Berry Farm. In the console window here, what you can see is the direct reporting of the SDR signal level, as well as the metadata that happens when the transmission ends. And during the transmission, you can see that signal level shifting in direct line with the way that Jack is reporting the signal level back. So this was the core functionality of SignalBot, was being able to actually determine what the signal level was from the SDR and create actionable Python functions based on that signal level. This is a view of what the actual streaming computer would look like when it was streaming. So in the back, you see the GQRX waterfall window. In between the stack, you see the console window that we just saw in the previous video. And in front of all of that is basically the stream manager for SignalBot. This allowed my direct control of the signal system, including allowing for the adjustment of the logging squelch. So if my noise floor was elevated, I would be able to bring that logging squelch up and adjust for that. It gave me live feedback if I was getting a transmission or not. I could also do things for the YouTube functionality, like send a message directly to the YouTube chat, and also do things like setting the chat and the broadcast ID for the YouTube API. And so what we have is the win. We have the transmission metadata of these signals that are coming in, the start and stop time, the total length of the transmission, the average signal level from GQRX, the average noise level from GQRX, and a calculable signal to noise ratio, but we don't have the who. And I realized that was a critical part of trying to track a jammer. And so we developed the canned ham, an AI-driven audio classifier. So I entered a stage of rapid development of an audio classifier for analog transmissions using generative AI. I started development in January 2023. I based it on PyTorch for Python. The classifier is a hybrid convolutional recurrent neural network. It trains and predicts based on 2-second waveforms, and it uses Mel frequency septural coefficient audio feature extraction. It attempts to predict call signs of analog transmission recordings. The data collection for training started on March 18, 2023, and model training started in April of 2023. The first prediction model reached lost target on April 20th. And what I quickly realized that if I was going to do a machine learning project like this is that I had to have critical data, and the data had to be labeled properly, because if you want to teach a computer to recognize a transmission, you have to tell it what that transmission is going to sound like in the first place. So what that involved was going through an average of 500 to 1,000 transmissions per day and applying call sign labels to them in the data. The first training set included 28 unique call signs, 4,448 amateur radio transmissions, and that broke down into 25,396 2-second audio waveform samples. It did not account for static, pirate signals, or RFI. And this is kind of just a glimpse at what that looked like. So this training process was a rolling training process, where as new transmissions came in every single day, I would apply, once I had my first running model, the predictions to those, thus applying any kind of labeling that I could beforehand. And then I would go through and correct the labeling so that I had accurate data, and thus then being able to roll that data into the next training. That also sped up the labeling significantly, because as the models progressed and became more accurate, my labeling process and confirmation was less and less work. And so after that first model, we had Big Boy, my second model. The training started on at 7:30 a.m. on April 22nd, and the dataset contained 12,364 transmissions with 67,204 2-second waveforms. It had 64 unique amateur radio call signs, and I was one excited Big Boy. But people wonder, wait, how do you train the model without a GPU farm? I thought we needed these fancy graphic processors in order to get artificial intelligence. Well, I was able to do it on my M1 MacBook Pro, and I did it with 16 gigabytes of unified memory and approximately 48 hours of training time, so it was not a fast process. This was CPU acceleration only for PyTorch. Although PyTorch does allow for M1 metal acceleration, I was not able to use it with my classifier. It took a lot of patience from me. Next, we had CoolCat. CoolCat started training immediately on the 24th. The dataset contained 12,796 transmissions. It predicted a dozen call signs at 90% or more, and 78 unique amateur radio call signs, and it did include RFI, static, and suspected pirates, which means that I started labeling those transmissions as such in the dataset. So if I had suspected RFI, I would label it as RFI. If I had static that got recorded with an elevated noise floor, I would label it as static so that the computer would learn to recognize static, as well as suspected pirate signals, so I could then later classify them individually. Next came Dubious Dog. The training started on May 6, 2022. The dataset contained 16,484 transmissions. That broke down into 88,512 2-second waveform files with 100 unique amateur radio call signs, and the training using Google Colab Cloud GPUs. And the training met lost target in 16 hours, which was significantly faster than training on my M1 MacBook Pro. So with this model, I was able to use the cloud resources from Google and run the training process within the cloud, trying to use there. But it was not a cheap process. Each time you tried this, it was about $5,200 worth of computing power. Finally, we had Earnest Elephant, which training started on June 13th, 2023. The lost target met at almost 72 hours later. The dataset contained 21,572 transmissions with over 4,000 minutes of recordings, 148 unique amateur radio call signs, and the training I did again on my M1 MacBook Pro. And this is the result.
K6WOR, K6OS.
Yeah, go ahead.
Hey, good morning, Dick. Now's a good time to get on the other frequency like I showed you last night, because early in the morning like you get up like me, you'll hear England, all those guys on that frequency if you get a call. Early in the morning or late at night, that frequency will get active, QSL.
Oh yeah, yeah. I'm on our regular one now.
Which one are you on now?
This conversation goes on for a while. In fact, I can send you guys the link. This is actually an excerpt directly from one of the YouTube archives from this is June 20th of this year. And if you've noticed it down in the bottom right hand of the screen, you can see canned ham running live on the stream. What's happening is as these waveforms are recorded, they are recorded directly into a folder. Canned ham is watching that folder like a hot folder. As the waveform hits it, it breaks it automatically into 2-second chunks, makes a prediction on each chunk of the waveform, and then averages that prediction to develop or to associate a call sign that the computer thinks that transmission is from. If you notice, it works pretty well. It gets all of these except for Fred's last transmission, which I think, according to the metadata, is only 1.8 seconds long. Therefore, it would not have had a prediction made upon it because it did not meet the 2-second minimum. It is possible to train these models on less time. Experimenting with the amount of time that it is predicted upon and many different factors in the training process is one of the ways that you can improve these models, but it takes a significant amount of computing time to be able to test all of these. So I did want to show you one other thing in this process, which is when I realized that the stream had kind of hit and the classifier had hit the progress that I'd wanted to make.
On June 28, 2023 at 9:40 a.m. PDT, amateur radio operator November 6 Juliet Zulu Tango was automatically live spotted at the SoCal Simplex Archive during the station's Summits on the Air activation of San Gabriel Peak, W6/CT019.
QCQ, Summits on the Air from San Gabriel Peak, 6,000 feet. Listening for any station anywhere, November 6 Juliet Zulu Tango. November 6 Juliet Zulu Tango.
The archives recently implemented artificial intelligence-powered transmission prediction system named Canned Ham accurately predicted the strong SOTA signal as it was received into the San Pedro's live stream monitoring SDR. These automated and live station spotting results mean SOTA input activators without access to internet communications can be aided in their pursuits for contacts, in addition to giving stations the ability to do post-review of their logs and evaluate overall transmission quality of the activation. Stations that frequent the 2-meter simplex call frequency in the Southern California area and are heard by the Archives monitoring station will have their transmissions ID'd and trained into future prediction models for the Canned Ham live spotting system. You can tune into the SoCal Simplex Archives 24/7 365 live stream by visiting the YouTube channel and subscribing now.
Okay, 7-3, have a great day, N6JZT.
When I saw this SOTA activation come across in my transmissions, and I realized that the system had accurately predicted and spotted the operator, it made me realize that the system had met the target of what I had set out to do, which is that it recognized a station that I didn't recognize. I kind of took pride as I was going through this data validation and labeling process that these were stations that I recognized, that I talked to, that I listened to every day on frequency on 2 meters. And so doing the labeling was actually quite fast for me. That was my own benchmark. Could the computer recognize a station that I couldn't with my own ear and do it faster than I could with my own ear? I didn't recognize N6JZT, but my computer did. And that was the point, that the computer learned what that station sounded like and was able to spot it in the middle of a live SOTA activation. And therefore, the Canned Ham classifier had met its target. So what's next? Will the SoCal Simplex Archive keep streaming? It needs institutional backing and torch holding. Because the reality is this kind of program should not be run by a single person or operator. There were direct threats against me during this streaming process. I had people tell me they were going to come to my house and pull my antenna down. I had people tell me they're going to come into my work and get me fired. So this was a very real legal implication and physical violence implications that were involved with this program. I think that if we are going to do self-regulation of the frequencies and be responsible amateur radio operators, there are institutions like ham radio associations and clubs. There are ham radio clubs on college campuses, physics departments that have electronics programs and clubs that I think would be better suited for taking on a program like this. And it needs a building of a network of monitoring stations. Obviously, a single source of recording is not ideal. But if you had a network of monitoring stations, you could log on, tune up your radio, and see where you're hitting. How far is my signal making it in my local region? And it's the same way that people do web SDRs, but it's a little more direct. Improvement for the entire project, improving the scientific approach to signal level measurement, not having a calibrated SDR, understanding the relation of what a DBFS level is and the fact that it needs a scale given with it to determine what that actual signal level is. Throughout this entire process, I recognized what the scale was. I could see what the stations were and see how loud they were coming in. One thing that I would do is calibrate the SDR and be able to turn the data into a relatable S unit measurement that ham radio operators could understand and conceptualize. Also, refining of the classifier itself with more layers. This was a basic classifier. I think that improving the technology could definitely improve the classification skills of it. And finally, commercial applications. Human resources departments that need to track their employees' use of radios. This is simple in digital environments, but there are a lot of radio systems out there that are still analog, that still need transmission tracking. It will take a program like SignalBot to be able to do so. So do we have our cake and do we eat it? We don't, because we don't know the where. And when we have things like multiple signal monitoring stations, maybe that's a future topic of discussion, to do time difference of arrival calculations, to be able to track jammers down to cities and neighborhoods more specifically, could be automated. And I think that's perhaps, discussion for another day. Thank you guys. I appreciate you all taking the time to listen to my presentation. I realize it was a little long. Thank you very much.